Good morning to you once again. You are welcome to today's lesson. So, in our previous lessons, we talk about indices. We talk about the laws of indices and solving equation involving indices, which is in our first video. So, if you are going to watch that one, I will encourage you to go and watch the first and second video on indices. So, today we'll talk about logarithm or log, simply called log. Right, so before we start, I'll humbly appeal to you to subscribe to my YouTube channel, that's Teacher Foster Media, for any updates or any information that we may have. Okay, so we'll talk about logarithm. So logarithm and indices are one coin of two sides. If you really understand the concept of indices, logarithm will be very easy for you because it's just an extension of indices, right? So logarithm and indices, they are brothers and sisters, right? Or they are friends. And once you understand one, the other one is easy to understand, right? So we'll talk about logarithm or log, right? So as I've always been doing, before I treat any topic, my first reference document will be the syllabus to know what the syllabus is asking for, right? So if you pick the syllabus for SHS and if you check the content for log, it talks about three things. One, should you treat relating indices to logarithm. Indices and log, how do they relate? They say we should treat that one. Then they say we should also treat laws of logarithm or laws of log. As you have laws of indices, we also treat laws of log, right? Then we also treat equation involving log or equation involving logarithm. Then we'll talk about anti-log and how to use the four-figure table or logarithm table and how to use calculator to solve log. So these are the main things that we'll talk about: relating indices to logarithm, laws of logarithm, anti-log, then using calculator and table, that's the four-figure table, to solve log, right? So not to waste my time, let's start with relating indices to logarithm, right? So that's our topic, logarithm. So our subtopic will be so they say we should talk about relating indices to logarithm in base 10. Right, so we'll start from base 10, then we'll build upon that. Right, okay. So let's see something. If I have 100 and I want to express it in indices form, right, it will be 10 squared. You know indices, right? Okay. If I have 81 and I want to express it in indices form, it will be 3 exponent what? 4, right? Then the last one, we have 16,807, and if I want to express it in indices form, it will be what? 7 exponent 5, right? Let's take the last one. If I also have 64, and I want to express it in indices form, it will be what? 2 exponent 6. That's 2 multiply itself what? 6 times 2 times 2 times 2 times 2, right? So I want to write this 64, which is 2 exponent 6 in logarithm. I want to relate indices to what? Logarithm. If I want to write 64 in log form, how will I write it? It's very easy, it's very simple. Let's pay much attention here, because here is the concept of logarithm. The moment you understand this, every log problem will be very easy for you, right? So writing 64, which is 2 exponent 6 in log form, is very simple. So let's see what we have. So let's pay much attention with this, because this is the whole idea of logarithm. Okay, they said, so it says 64 is equal to what? 2 exponent 6, or 2 power 6, or 2 in the 6, whichever way is the same. And it says 6 is the index and 2 is the base. So the 2 being the base, this 2 being the base, then the 6 being what? The exponent. Let's take note of these things. So 2 is the base, then 6 is the what? The exponent, or what? The index. So we have 64, which is equal to what? 2 exponent 6. if you want to write it in log form, or if you want to translate this 64, which is equal to 2 exponent 6 to log, it's very simple. So we can say that 6 is the logarithm of 64 to base 2. 6 is the logarithm of 64 to base 2. So what we just did was this 64, which is equal to 2 exponent 6, the base 2. So we will write it here, base 2. We know that when we are reading logarithm, there is log 64 to the base 2. So we will bring the base to where the base is. Right. Then the 64, we'll bring it in front of the log. Then our exponent, we'll write it here. Very simple. So we'll maintain this the base. Logarithm to this where the base is. So we'll maintain the base. We'll just bring the base here. We'll bring the 64 in front of the log. Then our exponent will make it equal to that. Okay, so let's take another one. So another example. So 100, which is 10 exponent 2. I want to write it in logarithm form. Right. So as I said, so I'll write my log. Then I'll bring the number on my left hand side in front of the log. Then the base, which is 10, I'll bring it here. Then equal to what? The exponent 2. I'm done. Very simple. Then another example 2. So 81, I want, which is equal to 3 exponent what? 4. I want to write it in log form. Very simple. So I write my log 81. This my base is 3. I write it over here. Then I'll bring my exponent to the right hand side. Very simple. So in other words, if you are moving from indices to logarithm, the base, which is big here, will now become small. Then the exponent, which is small here, you write it big. Right? Another way, right? The base, which is, in writing, when you are writing indices, you write the base to be big, then the exponent to be small. But in logarithm, the base will be small, then the exponent will be what? Will be big. Right? So try this one. 3. You want to write 125 in logarithm. So kindly try it and see. It's very simple. So this is all that we talked about, relating logarithm to indices. In base 10, you can do it in any base, because here is base 3. The basis is base 10, here is base 2. So the moment you understand it, it's just the application of the knowledge of what? Indices, right? So this is very simple. This is the basis of what? Logarithm, right? So let's move on to talk about the okay, so let's look at it in generic form. right? Okay, so let's take more examples. Okay, so in generic form, you say the logarithm of any number b to the base a is. So when you are reading log, so there is log b to the base a. This is how you write it. So if I said log 20 to the base 5, so this is how you write it. Log 50 to the base 10. Log 50 to the base 10. This is how we write it. So if someone is reading to you, you have to know how to write it, right? So log 20 to the base 5. Log 50 to the base 10. So this is the meaning of this statement, right? Okay. So they said if log if log b to the base a is equal to c, then b will be equal to a exponent c. That is, if you want to convert logarithm to indices, that's what you do. As I said, a is the base, which is here, base. Then c is the exponent, which will be at the right hand side when you're writing it in the form of log. Then the b, right? So which is this? So you write it in front of, as I've explained earlier on, right? You write the b in front of the log, then the base, you bring it at the top, the bottom here. Then the exponent will be at the what? At the right hand side. So that's in generic form. Log b to the base a. This is how you write it. Then if you want to convert it back to indices, the base become the base over here, then equal to whatever result to give you will be the exponent. Then the b will be what will be in front of the log, right? So for example, so I have log 1000 to the base 10 equal to 3. Log 1000 to the base 10 equal to 3. Then they say I should write it in indices form. It's very simple. So this one will be called, as I said, you write the number in front of the log at your left hand side, which will be 1000, equal to the base. You write it, then you bring this one becomes what? The exponent. So if you check from your calculator, 1000 is equal to what? 10 exponent what? 3. Okay, so very simple. So let's take another example. So this will be example 2. So I have 1 over 100,000, which is equal to 10 exponent -5. And I want to write it in log form, right? So it will be equal to, so this is the number which will come in front of the log. Then this will be my base. Then this will be what I'll write on the right hand side, right? So I'll have log 1 over my base. This is the base, so I'll write it over here as my base. Then I'll bring my -5 at the right hand side. I'm done. So writing 1 over 100,000 is equal to 10 exponent -5. I'll get log of 1 over 100,000 to the base 10 equals to what? -5. Okay, so I'll give you, let me take one with decimal point, then I'll give you other to try. So example 3. So they have given me 0.3, which is equal to 10 exponent -1. They say I should write it in log, right? So I should convert it to log. So as I said, I'll write my log. And I'll bring the number on the left hand side in front of the log, which is what? 0.1. Then my base is what? 10. I'll write it here, which is equal to what? The exponent -1. I'm done. If you check your calculator, log of 0.1 to the base 10 to give you what? -1. Okay, so you try this for us to see. So 256, which is equal to 2 exponent 8. Write it in logarithm form, right? Okay, so this, we have finished with the first aspect, relating indices to logarithm, or how to write indices in logarithm form, or when you are given tax in log, they say write it to indices. You have to know how to write it. If it has been given to you in indices and they say write it in log form, you have to know how to write it. So this relating indices to logarithm, we are done. So let's move to the second aspect, which is the laws of what? Log. So laws of logarithm, let's take them one after the other. So as we have product law in indices, we also have product law in logarithm, and they are almost the same. Please note that if we are writing log and we don't write any base, it means they are in base 10. So anytime you see any log without a base, it's in base 10. Please take note. Anytime you are writing a log and there is no base, they are in base what? 10. Okay, so the product law. So the log of m times the log of n, if you expand it to be what? The log of m plus the log of n, very simple and straightforward. So when they are multiplying, you add. In indices, when they are adding, when they are multiplying, it's just the same thing. In indices, when the exponents are multiplying, you add. Here too is just the same principle, right? So we are just to know the laws of indices, then how to apply it. That's the most important thing. How to use it to solve tax, right? So this is the first law. So let's look at some examples. I have log of 4 times 8 into bracket base what? 7. So this will give me it should be log of 4 plus log of what? 8. Very simple. Right, let's take another example. So I'm done. Very simple. So let's move to the next law, which is the quotient law. The same as so it's the same thing. So for the quotient law, log of m over log of n, it should be equal to log of m minus log of what? N. Very simple. This thing, they are very basic, so we won't waste my time on them. So let's take an example. I have log of 24 over log of 13. So this one will give me log of 24 minus log of what? 13. Okay, so let's move on. Okay, so take example 2. So log of 52 over 17. So do it. And another one. This one to do it. Right. Okay, so that's very simple for the quotient law. And let's talk about the third law, which is the exponent law. So for the exponent law, they say you have the log of x exponent y. So if you have such, the exponent, which is y, will come and multiply the log. Very simple. So the exponent log of x to the exponent y will be equal to what? Y log what? X. Very simple. So let's take example. So log of 10 to the base 4. Log of 10 exponent 4 to the base 4. So which will be what? So 4 log 10 to the base what? 4. Very simple. So example, this is example 1. So log of 15 square, which will be equal to what? 2 log what? 15. Very simple. 2 log 50. So try this one. So solve these ones. Log of 34 to the exponent 7. Log x squared. Then log y exponent 7. So try them. Okay, so we'll talk about other laws, or in some of the books they talk about it. They say they are properties. So whether they are laws, whether they are properties, they are the same. The most important thing is how to know them, how to apply them, understanding and applying them is the most important thing. The weather properties, weather laws, they all mean the same. So the fourth one, so logarithm of 1 to any base is 0. I'll show you why. So log of 1 to any base is what? 0. So as we learned earlier on, we can prove it by writing this log in indices form. Right. So if you want to write this log in indices form, this our base, right? Sorry. If you want to write this thing in log form, sorry, we want to write this thing in indices form. We want to show why log of 1 to any base is 0, right? So proof. So this our base. If you want to write it in indices, this our base. So it will come here. So A. No. The number in front of the log, right, which will come to the left hand side, so 1 equal to, this is our base, we write it here, A. Then the one on our right hand side becomes the what? The exponent, or what? The power, which is what? 0. Now we learn from indices that any non-negative, any non-zero number raised to the power 0 is what? 1. So A exponent 0 is equal to what? 1. That is why the log of 1 to any base is what? 0. So you just have to write the log in indices form. So in other words, A exponent 0 equal to what? 1. So that is why the log of 1 to any base is what? 0. Okay, so it's very simple. So if I have log 1 to the base 4 equal to what? 0. Log 10 to the base 7 equal to what? 0. Right. If you want to write it. Oh, sorry. Log 1 to the base 7 equal to what? 0. So if you want to write it, the number in front of the log, as you said, you write it on the left hand side. So 1 is equal to, this is our base 7. Then the number on our right hand side become our what? Power, or the exponent, which is 1, 0. So 7 exponent 0 equal to 1. In other words, 7 exponent 0 equal to what? 1. So any log or log to 1 to any base is what? 0. Let's take notes, right? So let's move to the fifth one. So log of its own base is equal to 1. Log 5 base 5 is 1. Log 6 base 6 is 1. Log 10 base 10 is 1. Right, so log to its own base is what? 1. So this is the fifth one. Log of its own base is what? 1. This one we can use the same approach to what? To prove it. Right, so let's see the proof. So these are some of the basic things that I want you to know. That's why I'm proving it. I want you to understand it very well. Right, so as we know, or as you want to write it, you want to write this one in indices. So as we said, the number in front of the log, you write it at your left hand side. So write our a over here equal to write our base a. Then we write what is on our right hand side as the what? The exponent, right? Which is exponent what? 1. So in indices, we know that if any variable is there without, or any number is there without an exponent, it has an exponent of what? 1. So which is what? A exponent 1 is equal to what? A exponent 1. Which means what? They are what? This which is what? A equal to what? A. So it implies that any base to the exponent, any log to its own base is what? 1. Right? Any base to its exponent is what? 1. So an example. Log 10 to the base 10 is what? 1. Log 2 to the base 2, 1. Log 5 to the base 5 is what? 1. Right. Okay. So let's take some examples. Today we won't waste much time. We are almost done. We are supposed to talk about the laws of indices, then relating logarithm to indices. Okay, so and that's the most important thing that you are supposed to do. Okay, let me add this one to it. Let me add a sixth one for better understanding. So if I have the log of xy all over z, it will be the log of x plus, we talk about the product law, the log of y minus the log of what? Z. Right, so the log of x times y all over z will give me the log of x plus the log of what? Y minus the log of what? Z. Right, or z, whichever, however you say it. So let's take an example. So this is how you do the log of x multiplied by the log of, so the log of 4 multiplied by the log of 3 all over 7 will give you the log of 4 plus the log of what? 3 minus the log of what? 7. Very simple. For example 2. So this one you try it. Then another one. So you try this one too, right? Okay, so let's solve some examples on what we have done. Then we'll draw the curtains of our lesson to an end, right? With this one too, it can give it to you in an expanded form like this. Then you'll be asked to write it in simplified form. So if they give you, so let's take an example. Let's take an example. So they say we should simplify log of 2 to the base a plus log of 6 to the base a minus log of 4 to the base a, right? So we should simplify. So this is how we'll go about it. So we'll apply this law or this property. Okay, so when they are adding, I know that I'll multiply them. So I'll have then they are subtracting, so I will divide. So this which will lead to what? 2 times 6, which will give me what? 12 over what? 4, which will give me log 3 to the base what? A. That's what we are done. So if you are given it in an expanded form, you have to compress, you have to use the rule, this property to what? To compress it and find your final answer, right? So let's take 1 or 2 examples, then we'll draw the curtains for today. So example 2. So they say we should simplify 1 over 2 log 25 minus 2 log 3 plus 2 log 6. As I said, when it is without any base, it is in base what? 10. Right. Okay, so this is to simplify. So we'll simplify it. So first, what you are supposed to do is to take the numbers in front of the log off. So how do we take it off? We use the what? The exponent law, right? So 1 over 2 log 25 minus 2 log 3 plus 2 log 6. I'll make sure that this 1 over 2 is not here, this 2 is not here, this 2 is what? Is not also here. So how will I do it? I'll use the what? The exponent law. So this 1 over 2 become what? An exponent, right? So I'll have log of what? 25 exponent 1 over 2 minus log of 3 exponent what? 2 plus log of 6 exponent what? 2. So this is the first thing that you do. Anytime you are working with log and there is a number in front of it, in front of the log, you use the exponent rule or the exponent law to make it what? An exponent. Right. So let me proceed. So let me simplify them. So I'll just work with this one because of the half, which is what? The square root of 25, which is what? 5. So here I'll get log of 5 minus, I'll maintain this for a while. Log of 3 square plus log of 6 square. Okay, so I've now taken off the numbers in front of the log. So what will I do? I will apply the fifth law that we talk about. When they are adding, you will multiply. So here, when you are given a log problem like this, after you have gotten here, arrange your work in order so that you can easily simplify. So with this one, I will arrange the positives to one side, then the negative to another side. Or in other words, I write the positives first before I write the negative last, so that I can divide the negative by the what? By the positive. Please let's take note. So it will be what? Log 5 plus log 6 square minus log 3 square. This is what I mean, right? You arrange the positives first, or you write the positive first before you write part the negative, because the positive, there's a relation between the positives, right? So this one I'll get, when we are applying the product rule or the product law, so I'll get log of what? Into bracket 5 times what? 6 square all over. So yeah, it's multiplied. The divide is subtracted, so it what? It will divide all over what? 3 square. Right. So here I'll get the log of 5 times 36 all over 9, which will be log of what? 180 all over 9, which will be log 20. Now divide 1 to divide here 20. So this is my final answer. So please, anytime you are working with log and it involves negative, write all the positives first before you write one. The negative, that's the most important thing. Then you apply the rule, then you proceed, right? So let's take 2 more examples, then challenge is even 1. Then we draw the curtain. Today I'll be snappy. Okay, so our last example. So we have 2 minus so say we should simplify 2 minus 2 log 5. Please let's pay much attention over here. 2 minus 2 log 5. You know, this one, this 2, it doesn't have any log. So how will we do it? Or how can we introduce a logarithm in front of it? Please, let's pay much attention. So anytime you are given a number without a log and you are supposed to introduce a log, first we check the base in which the other log or the other logs has been given to you. So if you observe our work, we are working in base what? Base 10, right? So in this work, we are working in what? Base 10. And how will I get 2 if I'm working in base 10? Right? Or the log of what in base 10 will give me 2. So I know that 10 is, 2, I'm working in base 10. So 10 square will be equal to what? 100. Or let's write it well. 100 is equal to what? 10 square. So to write this thing in logarithm, right? So I'll bring log. I write the number on the left hand side in front of the log. The base is what? 10. Is equal to what? 2. This 2 over here. So in other words, this 2 is the same as what? Log 100 to the base 10. Or in other words, log 10 exponent 2 all over what? 10. Which will give me 2, because we have learned that any log to each base is the same thing. So log 10 base 10, which is 1, 1 times 3 is what? 2. So in simpler term, anytime you are working with a log and a number has been given to you and it is not in any log, right? Just write the base you are working with. The base you are working with, yes. Exponent the given number, that's all. Right? So instead of these 2, I'll just write what? I'm working base 10, so 10 exponent 2, which will be what? 100. Then you write it in a log form. Right? So this is, as I've done, 100 is equal to a 10 exponent 2, which I had what? Log 10 to the base 10 exponent what? 2. So I've changed this 2 to what? Log 10 to the base 10 exponent what? 2. Yes. So instead of 2, I have 10. Log 10 to the base, log 10 exponent 2 to the base what? 10. So instead of 2, I write this thing over here. Please take your time and listen to it very well. You understand it, right? Anytime you are working with a given a given base and you are given a number, just write the base to exponent of that number, then you write it in a log form. You get what I have had over here. I'll give you one to go and try. So instead of 2, I'll get what? The log of what? 10 squared is 2 minus 2 log what? 5. Right. So I'll proceed to simplify this one. So I'll get log 10 exponent 2 minus log 5 exponent 2, which will be log 100 over 25, because they are subtracted. So you divide, which I'll get log what? 4. Right, so because 25 divide itself 1, to divide 100 what? 4. So that's how far we have. So this is what we will do for today. Right, so please take your time, listen to the video very well, and pay attention. If you don't understand anything, just chat me or write it in the comment section. So let me give you some try work on this. Go try. So 5 minus 3, 5 minus 7 log 14, then 3 minus 2 log 8 to the base 5. So go and try this work, right? Okay, so thank you. Enjoy your studies. Bye bye.